to ABC News AGT Live.
ये है ABC News AGT Live.
Listen to ABC News AGT Live.
Arnold Chawan, one of the brilliant students, and twice bird topper in Madhyamik and HS exams from the reputed Shishupir Higher Secondary School in Tripura, India, has emerged as the bright star in the basic sciences who has been pursuing his integrated MSc degree from Center for Excellency in Basic Sciences in Mumbai, India. Has presented his poster on an interesting topic. He has cited the sundry aspects and facts on the HST view of the planetary nebula population in the southern galaxy, that is MA3. The pineal galaxy, also known as the Messier 101, M101, or NGC 5457, is a phase on a spiral galaxy 21 million light years, that is 6.4 mega per seconds away from Earth in the constellation Ursa Major. It was discovered by Pierre McKay in 1781 and was communicated that year to Charles Messier, who verified his position for inclusion in the Messier catalog as one of its final entries. On 20 February 2006, NASA and the European Space Agency released a very detailed image of the pineal galaxy, which is the largest and most detailed image of a galaxy by Hubble Space Telescope at that time. The image was composed of 51 individual exposures plus some extra ground-based photos. According to Arnold Chawan, planetary nebulae, that is a PNE, are the glowing shells of ionized gas and dust which are formed when low-mass stars leave the astrophysics giant branch. Let's better pay heed to his own words.
Hello everyone, Arnab Chauhan here. I am a third-year integrated MSc student from Center for Excellence in Basic Sciences, Mumbai. Let me take you through my poster on an HST view of the planetary nebulae population in the southern Pinwheel Galaxy or M83 Galaxy, on which I have worked with my supervisor Dr. Sauradeep Bhattacharya from Ayuka, Pune. Planetary nebulae are a type of emission nebulae. These are glowing shells of ionized gases and dust formed when low-mass stars leave the asymptotic giant branch. We have worked on finding the number of planetary nebulae in the inner disk of M83. We have used the Hubble Space Telescope Wide Field Camera 3 data of a broadband and 2 narrowband images for this. Planetary nebulae have bright characteristic O3, 5007 angstrom emission, and can be easily detected in a narrowband image centered on this line. And the knowledge about the galaxy obtained from their study is enormous. Planetary nebulae are discrete tracers of light, kinematics, and chemistry of their parent stellar population. This gives us idea about the galaxy structure and evolution. As a first step, I used source extractor to detect sources in the O3 and conducted photometry of broadband and H-alpha images at the position of source detection. At each field, magnitude at which at least 50% of artificially injected sources were not recovered was calculated, as beyond that we cannot trust the source detections. Planetary nebulae are point-like sources. We plot difference between narrowband magnitude and core magnitude versus narrowband magnitude for the artificial sources and obtain the 95% curves. Whichever sources fall within the 95% limit are identified as point selected sources. Next, we perform our color selection of the sources. Being emission nebulae, the O3 characteristic lines are quite stronger in planetary nebulae than in any other sources. To exploit this, we plot difference between narrowband and broadband magnitudes versus narrowband magnitude. We detect all point selected sources with narrowband magnitude minus, broadband magnitude less than -1 as color selected as well. Although we have removed extended sources and continuum sources, there is a contamination from other emission nebulae. To remove the contamination from H2 regions, we have used a criterion relating the ratio of flux in O3 and flux in H-alpha to the absolute magnitude in O3. By removing all possible spurious sources, a clean catalogue of all the planetary nebulae candidates is prepared, which are 587 in number. Further, we can find the alpha parameter, that is the ratio of the total number of planetary nebulae in the galaxy to the total bolometric luminosity of the parent stellar population. This helps to know about the age and metallicity of the M83 galaxy. The characteristic O3 planetary nebulae luminosity function, also called PNLF, which contains exponentials in absolute magnitude, can be used to find the distance of the galaxy from the absolute magnitude.